Hello everyone and welcome back. In this video, we are going to talk about another dynamic programming problem, and this time it's count ways to reach the nth stair. The problem says there are given n stairs and a person standing at the bottom wants to reach the top. The person can climb either one stair or two stairs at a time. Count the number of ways the person can reach the top. So as an example, we are given n is equal to 4 and output is 5. Now I recommend you pause the video and take your own time to understand the problem before we really start with solving this problem. Now this problem feels analogous to the coin change problem, and it is, believe me, but there is a significant difference. So the difference is we have permutations here. Permutations counts. And what is permutation counts mean actually? It's nothing but that the order matters now. In this question, the order matters. And we'll see as we pick up a test case or test example to work on with. For the sake of simplicity in understanding, let's take n equal to 3 as our example case. So we have a person who is standing at the bottom of the stairs and he is allowed to jump, let's call it jumps, he is allowed to jump one or two steps at a time. So this is what we are given, and for the sake of keeping things simple, we are going to take n equal to 3. So to reach 3, we have 1, 1, 1, 1, 2 and 2, 1. 1, 2 and 2, 1 are different because order matters. We have 3 ways in total to reach 3 stair, n equal to 3 stair. So let this be our stairs. Starting from 0, 1, 2, 3 all the way to n. I am drawing it for 6 because as we increase n, we can always use this. So these are stairs, 0, 1, 2, 3, all the numbers are stair steps, and this is an array or RDP where we will store the number of ways it is possible to reach the nth step. So we know that to reach 1 we have only one possibility, 1. 0 doesn't make sense, but since we are initializing it, we are going to take it 1 because we are standing there. Really, there is no real logic there, but we are going to take 1. And to reach the second step, we have 2 ways, 1, 1 and 2. So now even though we know that dpi for I equal to 3 will be 3 ways as we have seen above, let's develop a formula anyway. So it will be interesting to see how the formula works for the I equal to 3 that we already know, and since the formula works for I equal to 3, it will work for I equal to any integer greater than equal to 3. So for dpi minus 1, that is dpi minus 1 is dp2, we have 2 ways. One is simply 2, or the person other way is take 1 step and 1 step, 1, 1. So dpi is dpi minus 1. And why I am writing 1 here? Because 1 is nothing but allowed jumps 0. So it's allowed jump 0 is R1, and we are taking 1 jump to reach the third step. So since we are taking 1 jump to reach the third step, so we are coming from where? 3 minus 1, that is second step. We are taking 1 jump to reach the third step and we are coming from second step. So as I said, we are coming from I minus 1 step where 1 is the jump we are taking to reach the ith step. Now why I am doing into 1, dpi minus 1 into 1? It's because we are adding 1 to all the possibilities that we have to reach the I minus 1 step. 1, 1 is one possibility, 2 is one possibility, and we are adding just our jump to it, that is 1, to both the lists. So technically or logically, theoretically, the number of steps doesn't change, it's just the length is increasing but the count is still the same, so we are going to call it dpi minus 1 into 1. And why we have added 1? Because it is nothing but jump, and jump is 1 because we are given that allowed jump 0 is 1. Now we can repeat the steps for the next element in the array allowed jumps. So the next element is in the array allowed jump is 2, so we are going to add dpi minus 2 to our dpi. We are adding dpi minus 2 is there because that is the jump now, and that is coming from the array allowed jump, the first element with 0 indexing, so that is nothing but 2. So now we are coming to stair 3, that is I, from stair 1, that is I minus 2. The possibilities we have to reach the first stair is just 1, that is 1, and we are adding 2 to it because the jump is now 2. So the total number of ways to reach the third stair from the first stair is 1 comma 2. 2 is nothing but jump, and jump is nothing but the element from the allowed jumps array. So we are coming from I minus 2 step this time. I minus 1 was nothing but allowed jump 0th element, and I minus 2 minus 2, that 2 is coming from allowed jump first element. So if you visualize how we are reaching third step is, we are reaching with 2 possible ways from second step and with 1 possible way from first step, that is 2 plus 1, 3. So dpi equal to 3 is 3. So if I were to now formulate a formula, in a standard way it would look something like this. So I'll do nothing but rewrite this in a more standard way, that is for ag for allowed jumps in the allowed jump array. So we are iterating in the allowed jump array. Let's just not call it aj as a variable, might get confused afterwards, so we are calling it j. We are iterating in the allowed jumps, and dpi is nothing but dpi plus dpi minus j. So it's just another way of writing it. I am multiplying it with 1 because we saw that adding just one jump at the end of all possibilities doesn't affect the number of counts at all. But where is this I coming from? So I must define it as well. So I'll iterate I in range 3 to n plus 1, where n is nothing but the number of steps we want to reach. So we will go in a bottom-up fashion. We will keep sub-optimizing the steps unless we reach the nth step, and once we reach the nth step, we will return the nth step. In the meanwhile, I have also initialized the dictionary, initialized the array as well. dp0 is nothing but 1, dp1 is nothing but 1, dp2 is nothing but 2. Now, why did we bother to write for j in allowed jumps instead of just dpi is equal to dpi minus 1 plus dpi minus 2? This is because this allowed jumps could have been a huge array, and in fact, array or list, and in fact, it could have been user fed, something that is user fed. For example, a person can jump 1 step, 5 step, 10 step, whereas other person can jump only 1 step and 3 step. What will you do in that situation? So for different person, there is different capacities to which he can jump stairs at a time. Taking that into consideration, the list of allowed jumps can vary, and can vary in length and magnitude of the elements as well. So to tackle that, what we did is we standardized the procedure and we created the allowed jumps array for tackling that possibility. So now let's quickly jump to our editor and start with programming the solution. So over here what we have is countways function, and what we need to do is just implement our code into this function and run the code and ensure that our approach works properly. So the first step will be to create our DP and initialize each element in it to 0. So our DP will be of n+1 length because we will be playing one indexing. Now once the DP is ready, what we need to do is initialize the first few elements. So DP0 is 1 by convention and DP1 is 1, as we can calculate only one possible step is there, that the man jumps 1. Now we are going to iterate in range with variable I from 2 to n+1, and in that loop we are also going to iterate for j in range, j for jumps, j in not range, j in allowed jumps. We are going to iterate in the elements of an array named allowed jumps, and as I write this I realize I haven't defined allowed jumps, so I must define that. So I'll define allowed jumps as an array or list that is equal to and contains two elements 1, 2, that are the jumps that are allowed according to the question. Now dpi is equal to dpi plus dpi minus j, and at the end I want the function to return dpn, the number of ways to reach the nth step. So the output should be 5 for input of 4, and if I run this program it should return me 5. The program clearly is returning me 5 and is working fine. Now we know that instead of using the allowed jumps array, what we could have done is not used it in fact. So I'll comment out the initialization or definition of the array, and instead of writing the another loop, what I will do is dpi is equal to dpi minus 1 plus dpi minus 2. 1 is coming from, just those are the elements coming from allowed jumps. Directly I can write them instead of all the defining of a new list and proceeding with it. This also returns me 5, and this will also work fine for this case. So just to make my point, why were we using allowed jumps in the first place? It's because for a certain man, the question could have been given that the man can jump 1 step, 3 step, 5 step, all the odd steps till 11. And in that case, it would have seemed too bad, or if the list length could have been larger, it would have been impossible for us to write dpi minus 1, dpi minus 3, dpi minus 5, sum of dp minus I minus 7, all the sum of all the possible jumps. So for us to deal with those kind of situations, it's better to use an array instead of directly putting the element in place. With that, we have finished this problem, and that's it. Thank you for watching this video. I hope this helped.